Hi everyone. Today we'll discuss about probability chapter, which is the main important chapter, and even it's a very easiest chapter. In schooling we can find in state, CBSE as well as Icon, and further in intermediate also this particular chapter depth will increase. But up to 10th standard ICSE, CBSE, 10th, 9th, 8th, it's like easiest chapter. Students also will feel somewhat refreshment. They will enjoy like anything. Easily they can score marks and easily they will understand also. So about probability we'll discuss few points today. So probability, before going to discuss about probability, okay, we will discuss about the definition of random experiment. Random experiment means an experiment that can be repeated any number of times under identical conditions. Okay, the an experiment that can be repeated any number of times under identical conditions means all possible outcomes of the experiment are known in advance. Okay, all possible outcomes of the experiment are known in advance. So before going to do somewhat task, experiment in the sense before going to do somewhat problem or else somewhat task, we know that what is outcome means result, what is the resultant thing will happen. So the actual outcome in a particular case is not known in advance, is called a random experiment. The actual outcome in a particular case is not known in advance, is called a random experiment. Okay, so the thing is here, before going to perform an experiment, we know the outcomes, but actually which outcome it is going to come perfectly in a particular way we cannot say. Like before going to toss a coin, we know that what are the outcomes, head or tail we will get, but actually which one it is going to come we don't know. So that is the thing. And in the same way, dice, if we roll a die, so what are the possible outcomes? Everyone knows 0, 1 or 2 or 3 or 4 or 5 or 6 we will get. But which one it is going to come? We don't know. So in the same way, drawing a card from a deck of playing cards. So deck of playing cards means actually you know that 52 cards it will be. Out of 52 cards, 13, 13, 13, 13, 13 diamonds, 13 hearts, 13 clubs, 13 shades. Okay. So out of total 52, we are going to draw a card. So after drawing a card, actually out of 52, somewhat card we can expect. But the thing is, which card we are going to get, we don't know. So that is the thing. That is about random experiment. After random experiment, we need to discuss about trial. Trial means conducting a random experiment is known as a trial. So tossing a coin one time is one trial. Okay, so now next definition we'll discuss, Nana. So outcome, the results of the random experiment are called as outcomes. The results of the random experiment are called the outcomes. Just now we discussed, after tossing a coin, actually we know that actually head or tail we will get. Okay, later we need to discuss about one more definition, important definition: elementary event or simple event. Any possible outcome in the random experiment is called the elementary event or simple event. So after tossing a coin, getting head or tail are elementary events. When we are going to roll a die, we are going to get 1 or 2 or 3 or 4 or 5 or 6 are elementary events. So the collection of all these elementary events is known as sample space. So next definition is what? Immediate definition is what? Sample space we have to discuss. Sample space means what? The set of all possible elementary events or outcomes is called a sample space. So when we are going to toss a coin, sample space means what actually? H comma T. When we are going to roll a die, 1 2 3 4 5 6. So like that, actually these are the perfect examples of what actually sample space. Suppose when we are going to toss a coin, we know that actually head or tail we will get. Suppose two coins at a time we are going to roll, we are going to toss means, so obviously head tail head tail head we will get actually. Okay, this is about sample space. So next immediate definition of after sample space is event. What is event? A subset E of S is called an event. So if you take the life cycle of a human, first any human, like infant baby, he will take birth, later on he will grow up, later on he will go to he has to face adolescence, later on actually he is going to become family man, afterwards he is going to become old man, later on he is going to die. So out of these first few stages what we discussed, so suppose even if we are going to name as E1, E2, E3, E4, E5, out of 5 stages, all these 5 stages together we can call it as a sample space. Out of that, actually if you take any one particular event outside, that is called as an event. Okay, so like that. So event means what? A subset E of S is called an event. So when we are going to roll a die, getting odd number also is an event. Okay, odd numbers will get, even numbers will get, prime numbers will get, even composite numbers also will get when we are going to roll a die. Okay, so that is the thing. So here till now we discussed about random experiment, later on sample space, later on trial, after trial sample space, after that event, what is elementary event. Okay, all these things we discussed. Now equally likely events, equally likely events. So equally likely events means what? When there is no reason to expect the happening of one event in preference to the other, then the events are known as equally likely events. So two or more events, or in other words, two or more events are said to be equally likely if each one of them has an equal chance of occurrence. Two or more events are said to be equally likely. In an easy way we can define like this: if each one of them has an equal chance of occurrence. Or one more, in another words again, a set of events is said to be equally likely if there is no reason to expect one of them in preference to the other. Okay na? See, we won't give any preference of when we are going to toss a coin. Whenever if we plan, then one person will stick to head and another person will stick to tail. But randomly, if you are going to toss a coin on your own without playing any game with anyone, simply if you are going to toss a coin, actually what, you won't prefer anything, something will come. But whenever it is well, if suppose if you got outcome like head, it is going to prevent another trial and another trial. Okay, another means tail. Head is going to come means it is going to stop tail to come. If suppose tail we are going to get as an outcome, then tail is going to stop head to come as an outcome. Okay, this is about equally likely events. Next definition is mutually exclusive events. Two or more events are mutually exclusive if the occurrence of each event prevents the every other event. Okay, if E1, E2, E3, En, suppose n events actually are mutually exclusive events, then the if intersection, if we apply intersection between E1, E2, E3, E4 up to so on En something, we are going to get what? Pi. Means after getting 1 2 3 4 5 6 as outcomes, so 1 is one event, 2 is another event, 3 is another event. So there is no similarity between these all events. E1 intersection, E2 intersection means 1 intersection, 2 intersection, 3 intersection up to 6 means actually what, we won't get anything. That is called as mutually exclusive events. Next, one more definition: exhaustive events. Exhaustive events means all the events are exhaustive events if their union is the sample space. Okay, then we can call it as exhaustive events. So E1 union, E2 union, U2 up to so on, n union, n events actually we are going to add together, then sample space will come. Okay, like human cycle. So what actually, after becoming what actually for what old man actually, that is an event. It's an important part of an human psyche, of a human cycle. So one event we are taking out, that is called as event. Collection of all events as known as sample space. So here if we equally likely events, again if we discuss, when an unbiased coin is tossed, the chances of getting a head or tail are the same. In the same way, when we are going to roll a die, getting even number or odd number are same. When we are going to take a card, when we are going to draw a card from a deck of cards, then actually what, the chances of getting red or black cards are the same. Why? Because 13 cards will be in red in color, 13 another cards, sorry, 26 cards will be in red in color, remaining 26 cards will be in black in color. Total together 26 plus 26, 52. Again in 26 red cards, 13 diamonds, 13 hearts will be there. Again here in black cards, 20 out of 26, 13 clubs, 13 shades will be there. So like this actually what we can explain. Next, mutually exclusive events. Again I am explaining, see, two or more events of an experiment where occurrence of an event prevents occurrences of all other events are called mutually exclusive events. After writing exam output, if you are getting pass means pass marks are going to stopping the result of coming outcome like fail, yes or no. So like that actually. So here one example he has given, see, if two events are mutually exclusive, then they are disjoint sets. Disjoint sets means, suppose here one, if you observe the diagram, aces and kings. So here there is no similarity. Aces intersection k is equal to pi. Then we can say that it is disjoint sets. And here hearts and kings are not mutually exclusive. Okay, hearts means what actually? In kings also hearts will be there. Okay, now here if you observe the diagram, in that particular set a to 10 hearts are there. So here we should not give preference for hearts. If you are taking hearts means you have to take the preference for some other club or spade something. But here actually what, hearts and kings we cannot compare. That is the reason actually what, hearts, it is going to come like intersection part. Okay, so dear students, I think so whatever I explained you understood, I think so. And actually finally probability definition means what, the probability of an event E is equals to number of trials in which the event happened by total number of trials. So here actually what, here one experimental probability, take suppose 20 coins, please toss 20 times. So take a coin and toss it 20 times. So the number of possible outcomes to get heads, it is like example only, not exactly. Don't think that actually you will get exactly 13 times heads. One person randomly he got, more it can come, less also it can come, no problem. But we are taking an example actually. Out of 20 times we tossed a coin, then 13 times we got heads, means 13 by 20, so 0.65. So like that, probability of an event E is equals to number of trials in which the event happened by total number of trials. In the same way, we can also define total probability definition, theoretical probability, as P of E is equal to number of outcomes favorable to E by number of all possible outcomes of the experiment. Number of, again I am repeating, number of outcomes favorable to E by number of all possible outcomes of the experiment. Okay, so probability of getting, one example, see here actually we are going to toss a coin, then sample, S stands for what, just now we discussed, sample space. The possible outcomes are H comma T, head or T. Now if you consider like let E be the event getting head, we are preferring for head here in this example we are expecting, then E is the set containing the outcomes favorable to the event E, so that E is equal to H. So the probability of getting a head, P of E, is equal to number of outcomes favorable to E by number of all possible outcomes of the experiment. So is equal to N of E by N of S. N of E by N of S is equal to 1 by 2. Okay, so like that actually what, we can solve all the problems.